Okay, we're going to pick up in this video with problem number 22 from our practice test on Math Excel. Here again, we're dealing with an angle measure that's got a multiple on the inside of our grouping symbol. So when looking for the solutions, we should be prepared to go around the unit circle, in this case, 2 times. So let's think about this. Where in the unit circle does the x value equal -1/2? Well, that happens here and here. Now, normally I would say that the angle, and I'm going to use x in this case because I'm pretending that cosine of x is equal to -1/2. So I would say x, the angle measure, is this position, which is 2 pi over 3. And I would say that it's this position, which is, let's see here, that's 4 pi over 3. And most of the time I would stop right there. But remember, we're not solving for x, we're solving for theta, and x is used in place of 2 theta. So I'm going to go around the circle a second time because that was the trick we've been talking about. If I return back to this position here, not only is that 2 pi over 3, but with an additional rotation, an additional 2 pi radians, or 6 pi over 3, that turns into the angle measure 8 pi over 3. And if I continue down to here, again, not only is that position 4 pi over 3, but it's an additional 6 pi over 3 beyond that, 6 pi over 3 radians, or 2 pi radians, one full circle, and that's 10 pi over 3. Now, these would be solutions for the value x, but please keep in mind that x is being used in place of 2 theta. My job is to get theta by itself, so I should divide everything by 2 in order to isolate theta and to solve for theta. So theta in this case is, well, 2 pi over 3 divided by 2. That's 2 pi over 6. We'll simplify that in a second. Then we've got 4 pi over 6. We've got 8 pi over 6. And then finally 10 pi over 6. When these are reduced, 2 pi over 6 becomes pi over 3. 4 pi over 6, well, again, common factor of 2. That turns into 2 pi over 3. 8 pi over 6, 4 pi over 3, and 10 pi over 6 turns into 5 pi over 3 when those fractions are reduced. Now this problem is fairly interesting as well. We're talking about secant this time, so it's a slightly different trig equation than we're used to seeing. And the multiple on the inside of the grouping symbol is 5/4. This 5 theta over 4 would be the same as 5/4 times theta. Now 5/4 is 1 1/4, 1 and 1/4. So when we're talking about the potential solutions for this inside of a unit circle, we've got to consider all angles within 1 1/4 of a rotation. And so to solve these for secant, cosecant, or cotangent, I always return them back to a phrase with their reciprocal function. So if secant, and I'm going to think of the variable x again, if secant of x is supposed to equal 2, well, that would be the same as the reciprocal function, cosine of x, equaling the reciprocal of this number, which technically is 2 over 1. So let's say that cosine of x has to equal 1/2. So to say that secant of x is equal to 2, that's the same as saying that cosine of x is equal to 1/2. These two are reciprocal functions. These two are reciprocal numbers, so the equations are equivalent. And so now I'll ask myself, where does cosine equal 1/2? Where does the x value equal 1/2? Well, that's here and here. So our solution for x is at pi over 3. That was this first one. We'll continue to rotate around. That's, let's see, 1, 2, 3, 4, 5 pi over 3. And just because I'm preparing for it, one additional quarter of a rotation gives me this angle one more time. So we're not talking about 1 over 3. That's 6 pi over 3 additional radians. So that lands us on 7 pi over 3. Now again, these are solutions for x, and since x was equal to 5/4 theta, I should divide everything by 5/4, divide by 5/4, which would be the same as multiplying by 4/5. And so I'm thinking to myself, pi over 3, and again, this is mental math. You could use a calculator if you'd like as well. But pi over 3 times 4/5, I'm multiplying because that's easier to me than dividing. Well, I end up with 4 pi over 15. And my second answer, 5 pi over 3 multiplied by 4/5. Well, in this multiplication, this 5 and this 5 is going to eliminate. Otherwise, I'd have 20 over 15 that needs to be reduced, and I'll call this 4 pi over 3. And then lastly, the final angle due to the additional portion of the rotation, 7 pi over 3 times 4/5. Well, that's 28 pi over 15, and no need to reduce that. In fact, we can't reduce that. And I'm going to settle on these as solutions, and I know they're all good, but it's worth noting that if I had a unit circle cut into 15ths, remember 1/2 of a rotation is pi units, which would be represented by 15 pi over 15 if we needed to have this denominator, which is a bit unusual for us. We're used to having denominators of 6 or 3 or 4. But even if we had 15, that's okay. And then this position over here is 2 pi, which is the same as 30 pi over 15 with that denominator. And it's important to quickly consider this value because our solutions have to exist between 0 and 2 pi, which would be between 0 and 30 pi over 15 radians, sorry, not including this final position. And each of these numbers that we selected do exist in this domain. If we did not take the additional quarter rotation, we would not have found this solution, and MathXL would have indicated that our solutions are incorrect because we're missing this one. All right, number 24. This one backs us down in difficulty. I think this one's pretty straightforward. Let's subtract 1 and divide by 2, and that's going to leave us with sine theta equals negative 1/2. So here again, where is the x value equal to 1/2? Well, that's in these two positions, 7 pi over 6 and 11 pi over 6. For number 25, when does cotangent equal 1? Well, I'll subtract 1 from both sides and rewrite this as cotangent theta equals negative 1. And again, I'm not real comfortable with the reciprocal functions, doing those in my head, so I'll just switch this to tangent. And I can switch that to tangent as long as I reciprocate the value on the other side. The reciprocal of cotangent is tangent. The reciprocal of negative 1, technically negative 1 over 1, if we reciprocate that, becomes again negative 1 over 1. So it's kind of interesting, and if you recall your graphs of your tangent functions, these two points will intersect, or I'm sorry, these two graphs will intersect at a y value of negative 1, and therefore a common theta value is our independent variable as well. So thinking of our unit circles, where does tangent equal 1? Well, that's here and here. So where does tangent equal negative 1? That's this position and this position. When y divided by x equals negative 1, that's here and here. So this angle, of course, is 3 pi over 4 radians, and this angle around here, 7 pi over 4. And I'll walk through one more problem in this video. Number 26, 6 secant of theta plus 8 is equal to negative 4. Well, let's subtract 8 from both sides and then divide by 6. Subtracting 8 from -4 puts us at -12. -12 divided by 6 is -2. So when does secant theta equal -2? And as I said a couple times in this video, I'm not real familiar with the reciprocal function values inside of the unit circle, so I'm going to reciprocate this back to something that I am more familiar with. And if I reciprocate the function, I need to reciprocate this value. We'll call this -1/2. When does cosine equal -1/2? And that's here and here. So angle 2 pi over 3 and angle 4 pi over 3 are the positions